And then we are moving on to the final talk of the day. From Syenta, it's Jekaterina Viktorova, and she will be talking about electrochemical printing of multi-material electronics. Take it away. I don't know, let's see. There it is.
Hello, everyone. Thank you, Ram, for introducing all the advantages of electrochemical printing. So I guess I don't have to do a talk anymore. But please be gentle with me. So my name is Jeka. I'm the CEO and founder of Syenta. And today I'm going to be giving a talk on electrochemical printing of multi-material electronics. We came all the way from Australia, and the company has been in existence for only a year. But in that year, we've been able to deliver our first printer to our first customer, which has been the latest development since I've given my last talk. And this is quite exciting to be here today. This is my first in-person presentation at TechBlick, so very, very excited. So I don't need to repeat why we love printed electronics. I think we all are sold on the idea of making electronics in-house and building them really quickly, iterating the designs, doing the R&D, and then transferring that to roll-to-roll scalable manufacturing. Sounds brilliant. However, being in the field for the last 7 years, there's still a little bit more to be desired when it comes to the actual electronics that we're building. Predominantly, they still look like this. Silver traces on top of a dielectric, quite limited in itself, and here at Syenta, we saw that mostly due to the limitations of the materials that are available. And some of the companies that have recently spoken about that already made a point of nanoparticles being quite limiting. First of all, it's hard to make them. Second of all, it's hard to scale them up. And then once you actually fabricate the ready device, it's quite limiting in its conductivity, aspect ratio, you name it. So this was kind of the first major disadvantage we saw with existing technologies today. And the second one is that transition from R&D phase all the way to scalable and mass manufacturing is very complex for printed electronics. You basically have to redevelop your material stack and your process from scratch once you are happy with your prototype and you want to make thousands of things. So that's kind of inspired us to look at printed electronics from a different perspective and develop our own method. And we've developed a new method which is called localized electrochemical modeling. And this method works basically using a microelectrode, which is then immersed in a vat of a solution, which is usually using a precursor, for example, copper sulfate, as spoken by many today, and then using a highly localized electric field by using a conductive substrate and applying a voltage to either reduce or oxidize material using electrochemistry. So as a result, what you get when you use a technology such as this, you get a non-contact room temperature method of printing the material without any nanoparticles, without any clogging, and your resolution is a function of the electrode that you're using. So essentially, if you want to use a very fine electrode, your resolution can go down to 10 microns, and it can get as large as you want to imagine. The beautiful part about this technology, and I think that's one of the biggest advantages, is the near bulk-like properties. And when I talk about near bulk-like, I talk about electroplating type of quality. And this allows us to basically use our materials in established electronics applications that are already been around for hundreds of years, and we don't have to convince anyone to use our material because they know they're getting pretty much pure copper when we talk about copper. The disadvantage is you have to use a conductive substrate. So it comes with its own baggage, and this is where we cannot make dielectric coated with silver unless we use our own approach. And we found this little R&D trick where we essentially 3D print our material, and then we laminate plastic on top, and then we delaminate a finished structure. So this process is still currently in R&D. And the dielectric properties are still being developed quite a bit. But currently we work with several epoxies and PMMA and developing this process to be essentially scalable and deliver the mechanical stability that most of our customers want in their finished product. The advantage of using electrochemistry is the amazing material selection.